Smart Emergency Service has been designed with a vision to develop an online service that integrates the smart decision-making capability with the help of the semantic web rules defined in the ontology and provides quick and efficient emergency services to users. This project has been developed by Kushwant Kondabolu, Nitin Sandru, and Sinduri Gangapuram. This project has been developed as a part of coursework Knowledge Discovery and Management at University of Missouri, Kansas City for Spring 2011 semester under the guidance of instructor Dr. Yugyung Lee and TA Saurish Das Gupta. Here is the architectural diagram of our project. The core component of this architectural diagram is the context management service, where we design the ontologies, define the semantic web rules, and make use of inferred axioms in quick decision making. Also, we have used various web services like Google Maps web service for visualization and routing information, IP tracking and IP to location service, where we track the IP address and map it to the current location of the user, and YouTube API, and gathered some information on fire, medical, and police services. Here is the homepage of our website, where we have three important modules: Report Emergency module, Emergency Services module, and Emergency Service Login module. The Report Emergency module allows the user to report about different types of emergencies like fire, medical, and police. Emergency Services module allows all emergency service providers to register with our website. Emergency Service module authenticates the service provider against viewing the current emergency situations within their coverage area. Now, whenever the emergency service provider wants to register, he clicks on the appropriate service and will be redirected to the service, where he has to enter the service name, the available resources, and area. Instead of filling the area manually, they can use the IP to location service, which automatically captures the external router address and converts it to the location. As soon as user clicks on invoke, it will fill the details automatically. Now the service provider has to enter the service name, available firefighters, available fire engines, and the description of the service. As soon as he clicks on the register button, the service provider will be redirected to the registration success page. Now, whenever a user wants to report an emergency, for example, if he wants to report a fire emergency, he will be redirected to the appropriate page, where the user has to enter the details like username, the risk level, the area of emergency, the anticipated damage, the help available, and the scenario at the risk-prone area. Now, instead of filling the area of emergency details, he can quickly use the IP to location service to fill the details automatically. And now he has to enter the username, the risk level, anticipated damage, current help available, and description of the scenario. And as soon as the user submits the report, it will be redirected to the appropriate emergency service. Now, as the user has reported the emergency from Kansas City area, it will be redirected to the Kansas City Fire Department service. As soon as the KCFD service provider logs in, he can view the emergency areas. He can observe the risk-prone areas, the risk level and damage, medium, damage to life and property, situation critical, and current help available at the situation. To provide the quick service, the service provider can use the Google Map directions to get the directions automatically using the Google Maps API. So as soon as the service provider clicks on Provide Service tab, the information will be forwarded to the background ontology, where intelligent decision making takes place, and it provides with the appropriate solution. Now the dispatched service for the given fire report is: for medical category B service is dispatched, for police category B service is dispatched, the police service dispatched is KCMO, the fire service dispatched is Kansas City Fire Department, medical service is Kansas AMR, and you can see that the number of police, firefighters, fire engines, ambulances and medicals that are automatically dispatched based on the report, and the expert group that has been launched. In order to visualize the scenario, the service provider can click on the visualization, where the visualization is provided in Google Maps. Here you can clearly observe the critical emergency service area, that is the fire accident spot 5100 Rock Hill Road, Kansas City, Missouri, and the nearest emergency services that are quickly moving towards the emergency area. The police service, you can see KCMO with dispatched policeman 160, and the Kansas City medical service with 20 ambulances and 350 medicos, and the fire service with 600 firefighters and 10 fire engines dispatched. Similarly, the user can view the report on police medical emergencies, and the process takes place similarly. As a part of general awareness, we have included a few videos for the users to view on steps to be taken at fire emergency and tips at the time of emergency. File for the project, where we have defined many classes, properties, individuals for our project. As soon as the report is submitted, it will be forwarded to the ontology, where intelligent decision making takes place with the help of the rules defined and inferred axioms, and the decision is forwarded to the appropriate emergency service provider.